Welcome. This video provides a complete step-by-step solution for the January 2024 CSEC Paper 2 booklet. It is designed to help you understand the key concepts and boost your confidence. Before I work through this paper, I'm going to share 3 tips that can help you to get a distinction in this exam. Tip number 1. Master past paper practice questions. You need to practice. You're going to practice under exam conditions and you're going to get a timer to time yourself and to record your timing so that you can improve. Tip number 2. You need to review the yearly CSEC examination report. Every year CSEC releases an annual report highlighting students' common errors and areas for improvement. You're going to use this to avoid mistakes and also improve your answers. And tip number 3. You need to get a mentor. A mentor can provide guidance, study strategies, and personalized feedback to help you improve. So here we have question 1. So we want to express this as a single fraction in its simplest form. It's important to note that 4/15 here can be written as 8/30, and 1 whole here can be written as 30/30 as well. So let us go straight ahead and write 1 whole as 30/30. And let's put our bracket back there. So we have 1/30 plus 4/15 is 8/30 as well. Now inside the bracket here, the denominators are the same, so we can add this. So what we have is 9/30. So we have 30/30 then minus 9/30. And that gives 21/30. So in its simplest form, we can cancel this down. 3 can go into 21, 7, and into 30, 10. So what we have there is 7/10. So we have 7/10 as the answer there. Part B. A 2-story car park has a total of 1,020 parking spaces. At 6:30 hours one morning, 1/30 of the spaces are filled. During the next hour, no cars left the car park, but another 4/15 of the spaces are filled. So what we need to do is to note that 4/15 here can be written as 8/30. So let's do that. So this 4/15 is the same thing as 8/30. So the spaces that are filled, the total spaces that are filled would be 1/30 plus 8/30. So that's 9/30. So the spaces filled is 9/30. Spaces that are empty or not filled would be 21/30. So they want to know the spaces that are not filled. So all we need to do is to find 21/30 of 1,020. So we write 21/30 times 1,020. We can divide by 10 here, we cancel. 3 into 102 there is going to give me 34. So what we have is 21 times 34. 21 times 34. And that gives 714. Part C. Of the 1,020 spaces, 20% are on the top level. How many spaces are on the top level? 20% is 1/5. So we do 1/5 of 1,020. And 5 can go into itself, 1 there, and into this 204 times. So 20% would be 204. Part E. The cost for parking at the car park is shown in the table below. So we have the length of visit and we have the cost in dollars as shown here. Part 1, Michaela leaves the car park at 18:30 hours and pays $9.25. Determine the earliest time she could have arrived at the car park. So if she pays $9.25, we can see there in the table that she would spend more than 4 hours and up to 8 hours. So 18:30, and she pays that. So if we subtract 8 hours from 18:30, we should get 10:30. So 18:30 hours, and we subtract 8 hours from it. So that would be 10:30. So the earliest time she could have arrived would be about 10:30. Hours. Part 2. Danraj bought a weekly ticket for $40. That week he visited the car park 5 different times as shown below here. So 25 minutes. So if you look in the table, up to 30 minutes it's free. So there are no costs when he spends 25 minutes in the car park. So that would be $0. 7.5 hours. Even though he spends 7.5 hours. So $9.25. So we can put $9.25 there. And then 11 hours. Let's see. 11 hours. Danraj would pay $15. Wow. So let's put $15 here. 8 3/4 hours, so more than 8 hours, Danraj would still pay $15. It's a bit costly there, let's see. And 8 hours, Danraj would pay $9.25 there. So what we need to do is to find the total of this. Okay, and that gives us 15 and 15, 30 and 9, 25, 9, 39, 25 plus 9, 25, that's 48.50. So that's 48.50. And if we subtract the $40 that he pays, he would have saved $8.50 as required. So we subtract $40 from this, and we can see that he saves $8.50 as required. Okay, so let's move on to the next part of the question. Question 2. You're required to simplify the expression that is given here. So it's important to note that in the denominator here we have x minus 49 here. This is difference between two squares. So we can write x squared minus 7 squared. That would be in the denominator. So let us factorize this then. Let us simplify this. So it implies that in the numerator we have a common factor of x. So we can factor out x there. And that would be into x plus 7. And in the denominator here, since we have a difference of 2 squares, it means that we would have x plus 7 times x minus 7. And here we can cancel out x plus 7, and the x plus 7 here cancel out. So what we have there is just x over x minus 7. Okay, so in part B, we want to find the value of r when we have x squared times x to the 6 is equal to x to the r. Now, the bases here are the same, and we're multiplying, so we can add the exponents. Therefore, we have 2 plus 6. So what we have there is x to the 8 equals to x to the r. So it means that the bases are the same, therefore r equals 8. Part 2. Find the value of s when we have s cubed equals 8. Therefore, we can find the cube root of 8. So s equals to the cube root of 8. And that's 2. The diagrams below shows a triangle and a quadrilateral as shown here. All the angles are in degrees and are written in terms of A and or B. Part 1. For the triangle, show that 2A plus 5B equals 171. So we know that the angles in a triangle add up to 180 degrees. So let's add up these values in here. So we have A, add A there. So that would be 2A. These are like terms, so we add them. Then we have 3B plus 2B, that's 5B. 5B plus 9, and that should equal to 180 degrees. So if we subtract 9 both sides here, we get 2A plus 5B equals to 171 as required. Let's move on to part 2 of the question. For the quadrilateral, show that 7A plus 8B is equal to 342 degrees. Okay, so again, we're going to collect the like terms in A. So we have 6A plus 3A, that's 9A, subtract 2A, and that's 7A. So we can write 7A. And then we collect the like terms in B. So that's 2B plus 3B, that's 5B, plus 3B, that's 8B, plus 18 should equal to 360 degrees. So what we need to do then is to subtract 18 both sides. And we get 7A plus 8B equals 342 as required. Okay, so we are now on part 3 of the question, where we are required to solve the pair of simultaneous equations in 1 and 2 and find the values of A and B, and we need to show all working. So we have 2A plus 5B equals 171. So let's write that down. So we have 2A plus 5B equals 171. Let's call this line 1. And we have 7A plus 8B equals 342. Let's call this line 2. So here we're going to eliminate for A. Therefore, we need to make the coefficients the same. So we're going to multiply line 1 by 7 and line 2 by 2. So 7 times 2A there would be 14A, plus 7 times 5B, that's 35B. So 7 times 171 give 1197. Okay, and let's call this line 3. And then 2 times 7A, that's 14A, plus 2 times 8B, that's 16B, and 2 times 342 there gives 684. That's line 4. What we're going to do is to take line 4 from line 3. So we take this away from line 3. So that goes out. So we get 19B here. And 684 from 1097, that's 513. Okay, so what we're going to do now is to divide both sides by 19. So B equals 27. So we're going to substitute this value in line 1. So from line 1 we have 2A plus 5B. 5 times 27. And that equals 171. So we have 2A then plus 135 equals 171. So 2A equals 36. So A equals 18. So we have B equals 27 and A equals 18. Okay, so let us now tackle question 3. In the triangle ABC, AC equals 8 centimeters and BC equals 5 centimeters. Here you are required to use ruler and compasses only. Construct triangle ABC. The line AB has been drawn. So here we have the line AB. So we need to now draw AC. So we're going to use our compass and we need to open it out to 8 centimeters on our ruler. So that's 8 centimeters. And all we need to do now is to put the point of the compass at A here, and we're going to swing an arc above here like that. Okay. And then now we need to repeat the process now for BC. And we're going to adjust the line to 5 centimeters on our ruler. So that's 5 centimeters. Then we put the point of our compass at B. So we're going to cut it here. So we bisect it. Now we're going to draw the line AC. Okay. So C is at this point here. And then we draw the line BC, which is here. Okay, so C is at this point here. So this is C here. Okay. Now, the next part of the question, we are asked to measure and state the value of BAC. So BAC means that we need to measure the angle A. So let's see what we get for that. So we get our protractor and we put the 0, the center of the protractor exactly at the point A. We line up the 0 line with the line AB. So what we get there is about 39 degrees. So BAC is 39 degrees. Okay. Part B. So the diagram below shows an equilateral triangle FGH whose base is 13 centimeters and its height h is given here. So you're required to calculate the value of h, which is this measurement here. So we have a right angle triangle and we're going to apply Pythagoras theorem to this. So let's annotate the diagram here. Means that this side here would be 13 centimeters. And from here to here would be 6.5 centimeters in the right angle triangle. From Pythagoras theorem then we have h squared is equal to 13 squared minus 6.5 squared. So to get h, we find the square root of this. So we're going to have the square root of 13 squared minus 6.5 squared. Let's use our calculator to work this out. 13 squared minus 6.5 squared so that gives 11.3 centimeters to 1 decimal place, so h equals 11.3 centimeters. One decimal place. The diagram below shows three triangles P, Q, and R. Triangle Q and R are images of triangle P after it undergoes a double transformation. So let's see what they want us to find. So describe fully the single transformation that maps triangle P onto triangle R. So we can see that this is a translation by vector. Let's see the vector here. So we're at this point, so that's 1 unit, 2 units to the right, so we can write this as 2 right, and then vector 1, let's count that and see that's 1 unit there, up 2 3 4, so that's 4 units up. So what this is saying, this is a translation by vector 2 4. So we can write then that it is a translation by vector 2 4. It is, and we want to describe the single transformation that maps R onto triangle Q. Let's look at R. Okay, so triangle R is here. You can see that this is a reflection in the mirror line x equals 1. So it's a reflection in the mirror line x equals 1. So x equals 1. So we can write then that it is Question 4. Consider the following functions. F of x equals 2 minus 5x and h of x equals 5 to the x. Calculate the value of f4. So f4 means that we input the value of 4 in the function here where we have x. So we're going to have 2 minus 5 times 4. So what we have there is minus 18. H 0. So we have h as 5 to the x, therefore we're going to have 5 to the 0, and that's 1. Okay? 5 to the 0, that's 1. And then we want to find h minus 2 followed by f. So let's write down h minus 2. So we know that h of x is 5 to the 2. So we're going to put in bracket here h, which is 5 to the x, and then here x is minus 2, so 5 to the minus 2, followed by f, and we know that f is 2 minus 5x. So we're going to have 2 minus 5 times this function here, which is x. Therefore, we have 2 minus 5. 5 to the minus 2 is 1 over 25. And what we get there is 2 minus, because 5 here can cancel that. So what we have is 1 over 5 there. Okay? So what we get there is 10 minus 1 over 5. So that gives us 9 over 5. Okay. Move on to the next part of the question. So we want to find f inverse x. We know that f of x was given as 2 minus 5x. So first thing first, we're going to let f of x equals y. Let y equals f of x. Therefore, we would have then y equals 2 minus 5x. The first step we need to do then is to interchange the x term with the y term. Therefore, we have x here, and then we have 2 minus 5y. The next step is to make y the subject of the formula, so we find y. Find y. So let us subtract x both sides. Therefore, I have 2 minus x. Let us add 5y both sides. Therefore, I have 5y on the left now. To get y, we divide both sides by 5. So we have 2 minus x, all of that over 5. So it means that f inverse x equals to 2 minus x over 5. Part C. Given that f of fx is equal to a plus bx, determine the values of a and b. So we know that f of x, let's rewrite it. We know that f of x was given as 2 minus 5x. So we need to write f followed by f. So we're going to have 2 minus 5x followed by f. And we know that f was 2 minus 5 times the value of x, which is this. Therefore, we have 2 minus 10 plus 25x. That should be identical to what was given here, which is a plus bx. A plus bx. So what we have then is minus 8 plus 25x. Identical to a plus bx. So it means that a, by comparing the coefficients, it means that a here equals to minus 8 and b equals 25. Okay, question 5. The mass m in kilogram of 120 newborns at a hospital is recorded in the table below. Okay, so we have the mass in kilograms and we have the frequency, and you're asked to state the modal class. Well, the modal class there from the table, so we look for the biggest frequency here, and that's 30, and we'll read across. So the modal class is going to be in this category here. So m is less than or equal to 5.3 and greater than 4.4. So we can write that down. So m is less than or equal to 5.3 and greater than 4.4. So the modal class is in here. So we identify the biggest frequency and we read across. Okay. Part 2. Complete the table below and calculate the estimate of the mean mass of the 120 newborns. So we want to work out the midpoint here. So what we do, we need to add these two values and divide it by 2. So 5.3 plus 6.2, that's 11.5, and we divide that by 2, so we get 5.75. So this is 5.75. And then also here we want to find the midpoint. So we're going to add 7.1 and 8.0, and that gives us 15.1. Divide that by 2, we get 7.55. So this is 7.55. Okay, so to work out this value, we're going to multiply the frequency times the midpoint, and the midpoint here is 5.75 and the frequency is 29. So let's use our calculator to do that. So we get 166.75. Let's write that down. 166.75. Okay, and then now we need to multiply 8 times 7.55, so we get 60.4. So we want to calculate an estimate for the mean. So the total frequency here, so sum of f, sum of the frequency here is 120. And we need to work out sum of frequency times x. So let's get our calculator and work this out and add these up. 651.3 so the mean is the sum of fx over the sum of frequency over the sum of the frequency. So the mean is 5.43 to 2 decimal places. So in part 3, one of the newborn is chosen at random from the hospital. Find the probability that the newborn has a mass greater than 5.3 kilograms. So we need to look back at the table here. A mass greater than 5.3 kilograms would be from this region onwards. So what we need to do, we need to add up 29 plus 28 plus 8 and write that as a fraction of 120. Let me annotate this here. So from this region onwards would be greater than 5.3 kilograms. Therefore, as a fraction, we have 29 plus 28 plus 8, and that's 65. So we write 65 out of 120. So let's go to that part of the question then. So it would be 65 out of 120. And we can simplify this as well. So here 5 can go into 65 13 times, and into 120 goes 24. So it's 13 over 24. So in part B, you are required to complete the cumulative frequency table as shown below here. So we need to reflect on the frequency table that was given. So here we have the frequency. So to get the cumulative frequency, we need to add up these. So we have 7 plus 18 here, and we get 25. And this 25, we're going to add it to 30, so we get 55. This value 55 needs to be added to 29, and that's 84. So let's write 84 in here. And this value 84 added to 28, and that gives 112. And 112 added to 8 here should give us 120. Because that was the total number of newborn babies. So if you don't get 120 here, it means that you have added it up wrong. Okay, let's move on to the next part of the question. On the grid below, draw a cumulative frequency curve for the information that is in the table. Here we have the table, and you're required to draw a cumulative frequency from it. So I've plotted the points here, so we just need to draw the curve. Here we have our cumulative frequency curve drawn, and in part 3, you are required to use your graph or your diagram to find an estimate for the median mass of newborns. So from the survey, we know that there are 120 babies. So the median then would be, we identify halfway here, which is the 60th, and then we read across. And where it cuts the curve, we read downwards for that value. And on my graph here, it's showing, so this is 5.1, 2, 3, 4, 5.4 kilograms. So I can write that down. So that's 5.4 kilograms. So in question 6, you are required to use pi as 22/7. So the diagram shows a hemispherical bowl and a cylindrical tin. The diameter of the cylindrical tin is 12 centimeter and the height is 17 centimeters. And the radius of the bowl is r. Show that the volume of the cylinder is 1923 centimeter cube. Correct to 4 significant figures. So the volume of cylinder then, of the cylindrical tin volume, is going to equal to pi, which is 22/7, times the radius squared. The radius here is going to be 6 centimeters. So we're going to times that by 6 squared, times it by the height, which is 17. Let's get our calculator and work this out. So to 4 significant figures, we get 1923 as required. So we get 1923 centimeter cube. So 4 significant figures. Okay, so the bowl is completely filled with soup. Okay, so the bowl here is completely filled with soup. When all the soup is poured into the empty cylindrical tin, 90% of its volume is filled. Calculate the radius of the bowl. Okay, so 90%. So we need to find 90% of this volume to work out how much soup is in the bowl. So we're going to have 90%, which is 0.9 times 1923. So let's work that out and see what we get. And what we get there is 1730.7 centimeter cube. So this is the volume of the soup in the bowl. So now we can work out the radius. Therefore, we have 4/3 times pi, which is 22/7, times the radius cube should equal to this volume, which is 1730.7. Okay, so what we can do is to multiply the numbers at the top. So what we have there is 88r cube. 88, 4 times 22, that's 88 times r cube. All of that over 21 equals to 1730.7. So what we get there is 7.4 centimeter to 1 decimal place. So r equals 7.4. R equals 7.4 to 1 decimal place. Okay. In the diagram below, points L, M, and N are on the circumference of a semicircle with center O and radius 18. Calculate the total area of the shaded sections in the diagram. So what we're going to do, we're going to make sure we annotate the radius. Here, ON would be 18 centimeters. And also OM would be 18 centimeters as well. Centimeters. And OL would be 18 centimeters as well. So to find the area of the shaded sections here, it means that we need to find the area of the semicircle. So it's going to be pi times radius square, all of that over 2, minus the area of the triangle, which is a half, base times height, a half, the base times the height. So let's work this out and see what we get. So we're going to have pi, we're going to use pi as 22/7, so we have 22/7 times the radius square, which is 18 squared, all of that over 2, minus the area of the triangle, which is a half the base. The base here is going to be 18 and 18 at 36. So half of 36 times the height, which is 18. Okay, so upon simplifying this part here, we get 509.1. And when we half this 36, we get 18. So 18 times 18, that's 324. And we subtract that. So what we get there, we get 185.1 centimeters square. So 185.1 centimeters square. The diagram below shows the first 3 shapes in a sequence which forms a pattern. Each shape is made up of a set of small white counters and black counters. Part A, complete the diagram to represent shape 4. So let us study the pattern and see. At the base, the white circles, there are 3 in the first shape. So second shape there are 5. Then third shape we have 7. Therefore, for the fourth shape we should have 9 at the base. 9 white circles at the base. And if you notice here, the height for the white circle, that's 2. And then we have 3, that's 4. So for our fourth shape, we should have the height as 5 white circles. Okay, we need to bear that in mind as well. So the height should go up by 5. So we're going to draw our shape now, okay? So this is our shape. So we have 9. So we have, let's just write 3, 5, 7, 9. So the height here is 2. And that's 3. That's 4. So we should have 5 whites here. So that's 5. Okay? So this is our new shape. Okay? Okay, so we are following up from part A of the question from the pattern. The number of white counters W and the number of black counters B and the total number of counters T that form each shape follow a pattern. The values of W, T and B for the first 3 shapes are shown in the table below. Study the pattern of the numbers in each row of the table and answer the question that follow. So we need to complete part 1, part 2 and part 3. So part 1 is here in the table and we are required to complete the missing bits here. So in this column here we have the number of black counters. So if you notice here, this is 1 and that's 2 and that's 3. So we can see this is n plus 1. So it means that to work out this, then we should have, this is 1, 2, 3. So this should be 4 plus the constant 1 all squared. So 4 add 1, that's 5 all squared. So that's 25. Okay, for this part of the question now, we know that the shape is in this section here and the shape is shape number 4. And if you notice, for the total number of counters, we have a formula here. We have a formula down here. So all we need to do is to input the value of n, because n here has to do with the position of the shape. So what we have there is 3n squared, so n is 4. So 4 squared is 16 times 3, that gives 48. So let's write that down. So we have 48 added to 4 times n, 4 times 5 is 20, and then plus 2. So what we have there is 68 plus 2, that's 70. So this should be 70. We move on to part 2 of the question now. We are given these values and this value, and we want to work out the missing bits here. So from the column where we have the counters, the black counters, we have 144, and from this we can see that this is n plus 1 all squared. So we can write n plus 1 all squared and equate it to 144 to find the value of n. So part 2, we are required to complete this part and this part. Now, from the column where we have the black counters, we can see this is n plus 1 all squared. So it means that n plus 1 all squared should equal to 144. So we can use that to find the value of the value here, this value here, which is the position of the shape. So what we're going to write then is n plus 1 all squared should equal to 144. N here has to do with the position of the shape in the pattern, and that's n. So here we take the square root both sides, therefore we have n plus 1. Root of 144 is 12. We cannot have a negative value because it has to do with the position of the shape itself. So we subtract 1 both sides, so n is 11. So the missing term here is 11. We can put 11 in there, okay? Now, for this one now, we need to work out the value for this. Now, let's study this pattern. We can see this is n again, n plus 1. So we can write 11 plus 1 here then, because n is the position of the number, n plus 1. And then in the bracket here we have 2n. So it's going to be 2 times 11 plus 1. Okay, so let's work this out and see what we get. 11 plus 1, that's 12. 2 times 11, that's 22. Add 1, that's 23. So we have 12 times 23. And that gives 276. So it means that this value is 276. Okay, let us move on to part 3. So we want to work out the nth term for the white counters and also the nth term for the black counters. Now, upon studying this here for the white counters, we can see this is n plus 1. So we can put in this bracket here. So we write n plus 1 in here. So we have n plus 1 in here. And then upon studying this part, we can see that we're going to have 2 times n in the bracket here. So let's write 2, and then we have n, and then plus the constant 1. Okay, that would be the nth term for the white counters. Now for the black counters, we can see by studying the pattern here that this is n add 1 all squared. So all we need to write in here is n plus 1 all squared. So we have n plus 1 all squared in here. We now come to part C of the question. The expression for the total number of counters t equals w plus b in shape S is given by t equals as squared plus bs plus 2, where a and b are both positive integers. By substituting suitable values for s, show that the total number of counters in shape 1 and shape 3 in terms of a and b is represented by the equations. Here, we were told that in the question here that t equals w plus b. So let us put a box around this. So we have t equals w plus b, but also we were told that t is equal to as squared plus bs plus 2. Okay, so from the table we can see that t is w plus b. So if you should square this part of the algebraic form for the nth term for w, and also if you square this part and you add them together, you get the value of t, which is given here. So t is also equal to this. So let's write this down. So t is also equal to 3n squared plus 5n plus 2. n plus 2. So we have a choice to use any two of these equations here. So I'm going to use this equation and this. Okay, so when we have shape 1, it means that n is 1 as well. So we're going to write when s equals 1, n equals 1 as well. And these two things are equal. So let us write then as squared plus bs plus 2 would equal to 3n squared plus 5n plus 2. Since they are both the value of t, it means that they are equal. Okay, so what we're going to do then, we're going to substitute the value of s equal 1 here and also n equal 1 in this side. So what we have then is 1 squared, that's 1 times a, and that's a, plus 1 times b, that's just b, plus 2. When n is 1, 1 squared, that's 1 times 3, that's 3, plus 5 times 1, that's 5, plus 2. These two here would go out, that would be 0. So what we have left is a plus b equals to 5 plus 3, and that's 8. So we have found one of those equations. So let's write when s equals 3, n equals 3. And we're going to still use these two equations here. We're using this one and that one, okay? 3 squared, that's 9, times a, that's 9a, plus 3 times b, that's 3b, plus 2, and that is equal to 3 squared, that's 9, times 3, that's 27, plus 5 times 3, that's 15, plus 2. Again, these two here would go out. That would be 0. So what we have is 9a plus 3b equals 15 and 27, that's 42. And here we can simplify this. If we divide through by 3, we have 3a plus b equals 14. And that's the second equation that we require. Section 2. Answer all the questions in this section. So, the diagram below shows the graph of two functions on the same pair of axes. The lines G and H are perpendicular. So we have line G and line H, and they are perpendicular. That means they form a right angle as shown here. So part 1, you're asked to determine the equation that represents the line G. So the line G cuts the y-axis at 3 here. Let's just mark this. So this is 0, 3. So the y-intercept there is 3. And M, the gradient. So this is C. That's C. Right, C is that. M, the gradient here, is the change in y over the change in x. The change in y here is 3. and the change in x is 6 units. Therefore, the graph is sloping upward, so it's a positive gradient, so we have a half. So we can write the equation as y equals mx plus c. So we have then y is equal to m, which is a half, x plus c. C here is just 3. So that's the equation of the line that represents the graph G. So in part 2 we are asked to write the equation that represents the line H. So let's look back at the graph. So graph G and graph H are perpendicular, right? So if the gradient of graph G is a half, it means that the gradient of graph H, the gradient of graph H, M2, should be minus 2, because two lines are perpendicular if the product of their gradients equal to minus 1. So M1 times M2 should equal to minus 1. Therefore, if this is a half, M1 is a half, it means that M2 should be minus 2, and that is equal to minus 1. So that satisfies the rule. Therefore, we have the gradient of graph H, and we have a coordinate which is 4, 0. So we can use y minus y1 is equal to m into x minus x1. So we have y minus, let's use this as x1, and this is y1. So y minus 0 then would equal to m, which is minus 2, into x minus x1, which is 4. Upon simplifying, we have y is equal to minus 2x plus 8. Therefore, the equation of graph H is minus 2x plus 8. So let's write that in. So y equals minus 2x plus 8. And we want to find the coordinates of P, the point P. So let's look back at the graph. At the point P here, the two graphs, they intersect. Therefore, this equation, so we have a half x plus 3 and minus 2x plus 8. They intersect, they are equal here. So if we equate these two, we can find the value of x, and then we can find the value of y as well. So we need to get this value of x here, and also the y value here. So we need to solve these two equations by equating them. Therefore, we have a half x plus 3 is equal to minus 2x plus 8. Okay, so we can add 2x both sides. Therefore, we have, so that gives us 5x over 2 equals 5. So we have 5x equals 10. So x equals 2. So when x equals 2, we can get the value of y. So we know that y is equal to minus 2x, x is 2, plus 8. Minus 2 times, so that's minus 4, plus 8, so that's going to be 4. So the coordinate of P is x is 2 and y is 4. Part 1 of B, you're asked to write 4x squared minus 24x plus 31 in the form a into x plus h all squared plus k. Okay, so let us write 4x squared minus 24x plus 31. We want to write it in the form that is identical to a into x plus h all squared plus k. How do we do that? The first step then is to factor out the 4. So we have that would be minus 6x plus 31 over 4. The next step is to make it into a perfect square. So we're going to find half the coefficient of x, all squared. So the coefficient of x here is minus 6. So half of minus 6 is minus 3. So we write 4. I'm going to use this bracket here. Okay, so we're going to have half the coefficient of x here. So I would have x minus 3 all squared plus 31 over 4. But because the term that we add into the expression here is half the coefficient of x all squared, we need to also subtract it as well in order not to change the expression. The next step then is to simplify this part. So we have 31 over 4 minus 3 all squared there would be positive 9. So what we have there is 31 over 4 minus 9. And we can simplify this to have 31 minus 36, all of that over 4. And that gives minus 5 over 4. So the next step now is to simply use this 4 to distribute back throughout the expression. So what we're going to have is 4 into x minus 3 all squared plus this value, but I'm going to distribute back this 4 throughout. So I'm going to have 4 times minus 5 over 4. And here, this 4 here would cancel out this 4. So what we have then is 4 into x minus 3 all squared minus 5. And it is now in the form that is on the right here, which is a into x plus h all squared plus k. Right. It's important to note that the minus 5 here is the minimum value, and we can write the coordinate of the minimum point. What we're going to have to do is to equate this middle bit here to 0. X minus 3 equals 0, so and find the value of x. So x here equals to 3. So the coordinate of the minimum point is 3, and this is minus 5. So we're going to need this for part 2 of the graph, for the graph. So on the axis below, we want to sketch the graph of 4x squared minus 24x plus 31, indicating the coordinates of the minimum. So here we have the coordinate of the minimum point, and the y-intercept here would be positive 31. So on the y-axis, we're going to have a point here, which is positive 31. That's the y-intercept. Now the coordinates of the minimum is positive 3 and then minus 5. So it's a sketch. So positive 3 would be somewhere here, I would think. And then minus 5 would be somewhere down here. About here. So that's the coordinate of the minimum. And to sketch a graph, all we need to do is to so this is a sketch of the graph, and the axis of symmetry is going to be this line here, and that is remember this point here is this coordinate here is 3 minus 5. So it means that this value, x value here, is positive 3. So state the equation of the axis of symmetry, and that is x equals 3. Question 9. We have K, L, M, and N as points on the circumference of the circle with center O. XY is tangent to the circle at K, so we have XY here and it's tangent to the circle at K. The angle LKY equals 48 degrees and MKO equals 12 degrees, and angle XKN has 56 degrees as shown in the diagram here. Now you're asked to find the value of KOL given reasons for each step of your work. So let us annotate the diagram. So KOL means that we want to find angle O, which is this. So let's write it here, KOL. Right, so triangle KOL is an isosceles triangle. Therefore, that's the radius there, and that's the radius. So the base angles here are equal. That's key, okay? So the base angles here are equal. Right, so we know that XY is tangent to the radius at OK. So let's put in here, this should be 90 degrees then, if it's tangent, because OKY is 90 degrees. And if OKY is 90 degrees and we have 48 here and we have 12, it means that this angle should be 30 degrees. So the isosceles triangle KOL has base angle 30 plus 12, and that's 42 degrees. So this angle here is 42 and this is 42 degrees. Okay. So to get KOL, it means that angles in a triangle add up to 180 degrees. So if this is 42 and this one is 42 degrees, that would be 84 altogether. So we have 180 degrees minus 84 degrees. And that gives us 96 degrees. So KOL is 96 degrees. So we can write KOL equals 96 degrees. So the first thing we need to say is that XY is tangent to the radius. So we can write XY is tangent to the radius. The radius, which is OK. Okay, so let's put OK there, the radius OK. And then we need to say KOL is isosceles triangle. And then you also need to say that angles in a triangle add up to 180 degrees. And that should be enough. Let's move on to the next question. Find the value of each of the following angles, angle LMN. So let's look at our diagram. We want the angle LMN. So let's annotate this. So we have LM, which is this angle. So we need to mark this in red. Okay, so we want this angle LMN. Okay, so how do we do that? Well, we have a cyclic quadrilateral here, and if we know this angle, we can find LMN, and we know that angles in a cyclic quadrilaterals are supplementary Okay, so we already know that this angle is 30 degrees because xy is tangent to the radius OK. So if we have 48 and 12 here, that's 60. Add 30, that's 90. So this is 90 degrees. Okay, so this should be 30. Also, xy is tangent to the radius at OK, and xko is 90 degrees. So if this is 90 degrees and we have 56 here, it means that to find this angle we just take 56 from 90, and that's 34 degrees. So this bit here is 34 degrees. So now we have all of this angle as 30 plus 12 plus 34. Write them down. So we have 30 degrees plus 12 plus 34, and that gives us 76 degrees. So since angles in cyclic quadrilateral are supplementary, to get LMN we take 76 from 180 degrees. And we get 104 degrees. So LMN is 104 degrees. So let's write it down here. LMN equals, we can just say angles in cyclic quadrilateral are supplementary. That should be enough. Part B, we want to work out the angle KLO. So let's look at the diagram for that. KLO. So we have KLO. So we want this angle here. So let's mark this KLO. So we want KLO. So we want angle L. So KLO is this angle. The isosceles triangle KOL has base angle 30 plus 12, and that's 42. So this angle is 42 degrees. So KLO is 42 degrees. And we can just say base angles in isosceles triangle are equal. So KLO equals 42 degrees. Part C, we want angle MLK. So we want angle L. Let's look at the diagram. MLK. So we have MLK. So we want all of this angle here. So let's mark this in. So MLK. Right. So we already know that this angle is 30 degrees. Okay, we already know that because if that's 48 and that's 12 and this is 90, 48 and 12 is 60, so this should be 30. Okay, we already found KOL, and KOL was 96 degrees. Right, so now we have an angle at the center here of the circle, 96 degree, and also this angle is standing on the circumference, so we can say the angle at the center is twice the one on the circumference. Therefore this should be 48 degrees. So we have a triangle where we have 48 degrees and 30 degrees, so we can find angle L. So it means that angles in a triangle add up to 180, so we should have 180 degrees minus 48 and 30, that's 78 degrees, so that gives 102 degrees. So angle MLK is 102 degrees, and we can say that angle at the center is twice the one on the circumference. Therefore angles in a triangle add up to 180 degrees. So let's write that. Okay, so we now come to part D of the question. We want angle K and M. So let's look at the diagram and see what we get for that. Angle K and M. K and M. So we want this angle here. So let's annotate the diagram for that. So we have K and M. So we want this angle. Again, we have a cyclic quadrilateral, and we know that opposite angles are supplementary, and we found this angle already. Angle MLK was 102 degrees, so this angle is 102 degrees. So opposite angles are supplementary, therefore this angle should be 78 degrees. So we can just say KNM equals 78 degrees. KNM equals 180 then degrees minus 102 degrees, and that equals 78 degrees. So we now come to part B of the question. E, F, and G and H are 4 points on level ground. The diagram below gives information on the distances and angles between the points. And you're required to show that angle X is 29.5 degrees. So we want to show that this angle here is 29.5 degrees. What I'm going to do, I'm going to quickly just redraw this here and label it ABC because you are familiar with that. So if I just quickly redraw the shape there. So we write cos A equals to B squared plus C squared minus A squared, all of that over 2 BC. So this angle is proportional to this side, so we label that as B. This side is B. This angle is proportional to this side, so that's small c. This angle is proportional to this side, so that's small a. So we just label the triangle. So we're going to put in the values of A, B, and C and work out the angle. So we can write cos inverse A would equal to this. Let's use our calculator to work this out. So cos inverse 11 squared plus 5.3 squared minus 6.9 squared, all of that over 2 times 11 times 5.3, and that gives us 29.5 to 1 decimal place. So we have 29.5 degrees to 1 decimal place as required. Okay, so part 2, a vertical tower GT is constructed at the point G. So let's construct the vertical tower, which is going to be somewhere here. I'm going to be looking at that. T is going to be somewhere here. So the next part of the question, the angle of elevation of the top of the tower T from the point F is 31. So from F to the top of the tower. So let's draw that. So the angle of elevation, let's mark that in here. It's going to be all of this angle. So we have a right angle triangle here, TGF, and we're required to find the length of the wire that was used to secure the point T to F. So T to F, we want to find this length here. So we have a right angle triangle where we have this angle as 31, which is the angle of elevation, and we have the adjacent side given. So that's the hypotenuse. So we're going to use cosine. So cosine 31 degrees is equal to the adjacent side, which is 6.9, over the hypotenuse, which is TF. That's what we are finding. So we multiply both sides by TF equals to 6.9. We want to get TF, so we divide both sides by cosine 31. Okay, let's get our calculator and work this out. So we get 8.0 to 1 decimal place. So TF is equal to 8. So TF equals 8.0 to 1 decimal place. So in part 3, we are given that the bearing of E from H is 228 degrees. So let's mark this, the bearing of E from H. So E is here and H is here. So bearing is measured from north in a clockwise direction. So let's mark this in. So all of this angle from north right around here is 228 degrees. So we want to find the bearing now of H from E. So H from E. So we are standing at E here, and we want the bearing of H, which is going to be all of this angle here. Bearing of H from E. Bearing is measured from north in a clockwise, so we want this angle here. Okay, so let us annotate this diagram properly so that we can understand. I'm going to extend the north line down to south here so we understand what's going on. Okay, we know that all of this angle here is 228 degrees, but we can work out this angle here because this angle is alternate to this one, right? So we know that from here to here, let's mark this in red so that we understand what's going on. We know that from north to this line here is 180 degrees, right? So if we take 180 degrees from 228, we should get this angle here, and it will be alternate to this angle. So let's take 180 from 228, so we get 48 degrees. So this angle here is 48 degrees. So it means that this is alternate to it, so that's 48 degrees as well. So what we do, because this is 180, so if we subtract 180 from 228, we get 48 degrees. Therefore, the bearing of H from E is 048 degrees, because bearing is written in 3 figures. Remember that, okay? Right. Now let's go on to part B. We want the bearing of G from H. So we are standing at H, and we want the bearing of G, which is going to be from, it's going to be all of this angle here. Let's rub out this, and so we can annotate this properly. So rub this out. So we want to mark this angle here, the bearing of G from H. So from H, all of this angle to this point here. Okay. So how do we do that? Well, let's extend our south line. So we extend our south line here. So we want all of this angle to here. Okay. So how do we do that? Well, what we can do, we know that all of this angle here was 54 degrees. So if we subtract 54 from 228, we should get this angle, all of this angle here to this point. So let's subtract 54 from 228. So we have 228 minus 54 degrees. And what we get there is 174 degrees. So this angle is 174 degrees. From here to here would be 174. 174. Question 10. In the diagram below, O is the origin, OE equals 2EF, and M is the midpoint of EG. OG equals C. So let's annotate the diagram here, and OF is equal to D. So we have OG equals C. That's the vector C there. And OF is D. So from O to F is D. All of this length is D. But we were told that OE is twice EF. So we have OE here. If it's twice EF, it means that this would be 2 parts, and that would be 1 part. So the total parts would be 3. Therefore, this would be 2 out of 3 parts, and that would be 1 out of 3 part. Now, you're asked to find in terms of C and D in the simplest form FG. So FG here is our resultant vector. That's what we want to find. So how do we do that? Well, to get to FG, we need to travel minus OF and then OG. So FG then is equal to minus OF plus OG. We know that OF is D, so we have minus D plus OG, which is C. Part 2, we want to find EG. That's our new resultant vector. Let's annotate this. So we want EG, therefore, so let's write that. It's minus OE plus OG. We can see that OE is 2/3 D. So minus OE then would be minus 2/3 D plus C. Okay, so we need to find OM. So let's mark OM on the diagram here. So OM, and that would be our new resultant vector. So let's put our resultant on that. OM. That's our resultant. So OE plus EM. So let's write that. OM is equal to OE plus EM. So let's look on the diagram. OE here would be 2/3 D. So we can write that. So that's 2/3 D plus EM. We were told that M is the midpoint of EG. So if M is the midpoint of EG, it means that EM is half EG, and we have found EG, which is this. So we need to have a half of this. So EM then is a half EG, which is this here. So we would have a half times minus 2/3 D plus C. Okay, we can make the denominator into 6. Therefore, 2D over 3 would be 4D over 6. So let's write that. So we have 4D over 6. And then inside the bracket here, what we have when we simplify this, we have minus 2D plus 3C, all of that over 3. So we're going to make this into a 6. So we're going to times by a half. Therefore, what we have is minus 2d plus 3c, all of that over 6. Now the denominators are the same, so we can simplify the numerator. So what we have then is 1 6, then 2d from 4d, that's going to give us 2d plus 3c. So OM is 1 6 2d plus 3c. Part B, the matrices P, Q, and R are given in terms of the scalar constants A, B, and C. Given that P plus Q equals R, find the values of A, B, and C. So P plus Q equals R. So let's write that out. P is 3 minus 9, A, 7. That's P. Plus Q. Q is minus 1, B, minus 4, 1. That's Q. And we were told that it's equal to R, which is C minus 3 minus 4. And then 8. Right, so how do we simplify this? Well, step 1, you need to note that this column added to this column. That's the first step we're going to do. Therefore, we have 3 plus minus 1, and that's 2. Then we have A plus minus 4, so it's A minus 4. That's the first step. The next step is to add this column with this column. Therefore, we have minus 9 plus B. Minus 9 plus B. And then we have 7 plus 1, and that's 8. And that is equivalent to C minus 3 minus 4, 8. It's important to note that this column now is equal to this column. Therefore, we have C equals 2. C equals 2. And also we have A minus 4 equals minus 4. So we have A minus 4 equals minus 4. So from this we can see that A, we add 4 both sides, therefore A is 0. So this column now should equal to this column. So let's annotate this. So it's going to be this column equal to that column. Therefore, we have minus 9 plus B equals minus 3. So minus 9 plus B equals minus 3. So to get B, we add 9 both sides. Therefore, B equals 6. So we have found the values of A, B, and C. So A equals 0. B equals 6. And C equals 2. So we are asked to solve the pair of simultaneous equations using a matrix method. So here we have the pair of simultaneous equations. So first we need to write it in matrix form. So we want to write it in the form A x equals C. So here A would be the 2 by 2 matrix. So we have 5 minus 2, 2, and then 3 times xy, and that equals 44, 10. So that's the first step. You write it in matrix form. The next step is to find the determinant of the matrix A, the 2 by 2 matrix A. So let's do the determinant. So determinant of A there. We multiply the leading diagonal, so we find the product there. So 3 times 5, that's 15, minus the product of the elements in the non-leading diagonal. So 2 times minus 2, that's minus 4. So the determinant there is 19. The next step is to find the inverse of the matrix. So the inverse of the matrix is A inverse is 1 over the determinant, so 1 over 19, times, we interchange the elements in the leading diagonal here, so we interchange 5 with 3, so we have 5 here and then 3 here. Then we multiply the elements in the non-leading diagonal by -1, so -1 times positive 2 here would be -2, and then -1 times -2, that's a positive 2. So we have found the inverse now. So the next step is to multiply both sides of the equation by the inverse. So we're going to multiply the left hand side here by the inverse and the right hand side here by the inverse. So we have 1 over 19, 3, 2, minus 2, 5, times 5 minus 2, 2, 3, then xy, 3, 2, times 44, 10. It's important to note that the inverse times the matrix give the identity matrix, which is 1, 0, 0, 1, times xy equals to the right hand side. So let's multiply the right hand side. So we're going to multiply this row by the column. So first row by first column, and then second row times the first column here. So let's work this out. So we're going to have 1/19. 3 times 44, that's 134. Plus 2 times 10, that's 20. Minus 2 times 44, that's minus 88. And 5 times 10, that's 50. Okay, so on the left hand side, so we have x and y here. So we need to simplify this now. So we have 1/19. That's going to give us 154 when we add them. So that's 154. And that's minus 38. So 1/19 of 154 there is 8. And 1/19 of minus 38 there is minus 2. So x equals 8 and y equals minus 2. Here ends the paper.